This is 6.5 part 3. All right, so in this next question, they're giving us extra information here. So this says the first term, or find the first term, when the 6th term is 17 and the 25th term is 74. Okay, so anytime we have the little th, we know that that's an n. So we have an n here and an n here. And then it's telling us that the value of that n is 17. So that means this is our tn and we have another tn. Okay, so we've never had a question where we've had double values before. And it's asking us to find the first term. So we can choose either set of n and tn to use in our list. So I'm going to use these because they're listed first, but you could have also used this set. Okay, so I'm going to write my n is equal to 6, my tn is equal to 17, and then we don't have a d value, and we don't have an a value. Okay, it's not listed. We want to find the first term, so that's what we're looking for, but we need a d. So actually, we can find d because we're given two different n's and two different tn's. We can use this to find d. D means the difference, so we can calculate the difference between these values, okay? So the way we're going to do that is we need to know how much the tn has changed, and we're going to divide that by how much the n has changed to calculate how much it's going up each time. And we can use our old formula that we used for rate of change before, y2 minus y1 over x2 minus x1. So let's just label these. We'll label this one 1s because they're first, and we'll label these 2s just so that it falls into our formula, okay? And we're going to have our tn values be in the y position. So this is going to be our x1, that's going to be our y1, it's going to be our x2, that's going to be our y2, okay? So we're going to do 74 minus 17, and then we're going to do 25 minus 6. So 74 minus 17 gives us 57. So the number changed 57 places. And 25 minus 6 is 19. So it changed 57 places in 19 digits. So when we do that calculation, we get 3. Okay, and this is our d value. So it's counting up by 3. So we can put a 3 here. And then now at this point, we're going to use our formula and solve for a. So tn is equal to a1 plus d n minus 1. And we'll put in the information we know. So we know 17 is equal to, we don't have an a1, our d is 3, and our n is 6 minus 1. Okay. If you wanted to save a step, you can do this calculation in your head and just write a 5 down here. But I'm going to write it all out. So that gives us 5. Then we have to do this calculation. 3 times 5. So we get 17 is equal to a1 plus 15. And then we want a1 to be by itself, so we can subtract 15 from both sides. And we end up with a1 is equal to 2 as a final answer. Okay. So remember, when you're doing these, the th, one that has the th, that's going to be your n. And when you're putting it into your formula, it ends up being the equivalent to the x value. That's just something you have to remember. Okay. So then next with these questions, we're going to look at some word problems. So we're using the same formula here, but now they're giving us the information in sentences. So writing out our list on the side becomes very important. Okay. So first we're going to read the question. Jim had 35 baseball cards in 2016. Every year he adds 9 cards to his collection. How many cards will he have in 2027? So he's starting off with 35 baseball cards. So that's going to be our A value. Every year he's adding 9 cards. So that's our D. And they want to know how many cards. So they're asking us for our TN, what we have in 2027. And they're giving us 2 dates, 2016 and 2027. So we need to figure out how many years have passed in that time, and that'll give us our N. So let's write this out. So we have A1 is equal to 35. We have D is equal to 9. And then we have an N value of 2027 minus 2016, which ends up being 11. And we want to know TN, and that's question mark. Okay, so we'll write out our formula. TN is equal to A1 plus D N minus 1. And we don't know our TN. We know our A1 is 35, our D is 9, and our N is 11. 11 minus 1 gives us 10. So I'm going to write it like that. So now we have 9 times 10. So TN is equal to 35 plus 90. And then we can add 35 and 90 together. So we get 225. So he will have 125 cards in 2027. So once you pull the information out of the word problem, then the calculation is similar. Okay, we'll look at one more question. The growth of a colony of carpenter ants produces an arithmetic sequence in which the number of ants increases by approximately 80 ants each month. Beginning with 40 ants, how many months would it take for the ant population to reach 3,000? So it's saying that, so it increases by 80 ants, increases, so that's telling us that's our D. It begins with 40 ants, so that's our A. And how many months would it take for the population to reach 3,000? So they're telling us 3,000 is our endpoint, our TN, and they want to know N. So we can write out what we know. We know A1 is equal to 40. We know D is equal to 80. And we know, TN is equal to 3,000. We don't know N. So we'll set up our equation. TN is equal to A1 plus D N minus 1. Our TN here is 3,000. Our A1 is 40. We have 80 for our D, and then N minus 1. So we'll start off getting rid of our brackets, multiplying 80 to both these numbers. So then we get plus 80N minus 80. Then we need to combine the 40 and the negative 80. So we're going to have 3,000 is equal to 40 minus 80 is negative 40 plus 80N. We're going to add 40 to both sides. So we get 3,040 is equal to 80N. And then finally, we're going to divide by 80 so that the N can be by itself. So we get N is equal to 38. So it will take 38 months. Okay, and that's your final answer there. All right, so now you can do your homework for this section. So you have page 263. You can do number 10, just the left-hand side, and those will be questions similar to this one. And then you can do page 264, number 14 to 17, and that'll be some word problems for you to try out. And that's the end of this section.